All right, thank you everybody for coming to this session. Last day of EclipseCon, hope you guys have had a good conference so far. So I want to talk a little bit in terms of a lot of new architectures and a lot of new open source projects that we see coming down, especially with contributions from my company, Huawei. My name is Brian Che, and I'm the Chief Strategy Officer at Huawei. So if you look at the most popular open source projects that have been around for the last number of years, it's pretty clear that cloud computing technologies and cloud computing architecture has really been dominating the conversation and really dominating the adoption of what everyone is doing from an open source perspective. So over here, you can just get an idea of a lot of the different popular open source foundations that are out there and their projects, whether from Linux Foundation or CNCF or OpenStack and so on. And Huawei has been a longtime participator and a very strong participant in all these communities, typically at the highest level in terms of membership levels and also in the top tier in terms of our own developers contributing code. And I expect that these open source technologies around cloud computing will remain critical and strategic for quite some time. But there's a couple big trends that are starting to happen across our industry that is going to require a total rethink of architecture and open source for everything from how we do our hardware all the way in terms of how we build our applications. So the first big trend is that if you take a look at artificial intelligence and machine learning. Obviously, this is a really hot topic today, but most analysts predict by around 2025, so just in 5 years, AI workloads will consume about 80% of the compute capacity across all cloud data centers in the world. So this is a big, big shift because if AI and machine learning workloads are going to be the primary thing that people are trying to run across these data centers, that's going to require a different approach in terms of how we construct our applications and what are the open source technologies that we need around these. So that's the first big thing that is starting to change a lot of the way we need to think about how we build our applications. The second one is that we're starting to see a confluence and integration between what is happening in the cloud and what is happening from a device and an edge standpoint. So there's already been a lot of work, even here at Eclipse Foundation in terms of how do we start to build out these edge capabilities and then start to integrate them from cloud. A lot of the early work in this area has been taking what we've done in the cloud and starting to extend that to the edge. But we start to expect that as we go forward, and especially as devices become increasingly powerful and we look at IoT use cases, you're going to see the reverse become increasingly popular, which is that you start to see applications and architectures coming from the mobile devices start to infiltrate back into the cloud and starting to drive what is happening there from an architecture standpoint. Just a couple reasons we expect that to happen. First, if you look at the number of deployments and devices out there and just the scale of and speed of what is being deployed from a CPU standpoint in your mobile phones, orders of magnitude larger deployment footprint than what is happening in the cloud data centers. And so the second requirement, though, is that you're starting to see a lot of applications that are going to need to run across all these different footprints. And so if I want to build a smart home or a smart city or start to build intelligent applications everywhere, I need to be able to have similar architecture and similar compute capabilities everywhere that I go. And this is much more likely going to be coming from the mobile devices back into the cloud because of the increased power efficiency and also because of the application compatibility people are trying to achieve. So these two changes, how do we start to move compute from the devices back into the cloud as opposed from the cloud to the edge? And the second, how do we optimize these workloads for machine learning when it becomes 80% of our capacity in the data centers? These are the two big trends that we're taking a look at in terms of, okay, what does the next wave of open source look like? So across that, we've been starting to rethink everything from what do you need to do from a hardware standpoint, what do you need to do from a software standpoint, how do you rethink what happens from a device standpoint, how do you also deal with different mobile architectures, and how do you engage with developers across this? Because if we want to build a new wave of applications that is predominantly AI-oriented and that can run everywhere, then we need to rethink in terms of what we do across each of these things. So I'm going to go through pretty quickly now and introduce a lot of the things that Huawei has been investing in across all these different layers of the stack to say, as we think about this new era where we need to put AI into everywhere that we are, how do we start to architect these new approaches? So I'm going to start off at the hardware layer, and I'm going to build my way all the way up. So the first thing is that when you take a look at machine learning workloads, this is starting to drive a world where we need to go into heterogeneous computing architectures. Already, when you take a look at most training that's done in the cloud data centers around machine learning, this is not being done on a general purpose CPU. Most of these are at least going onto a graphics processing unit, typically from NVIDIA. But increasingly, you're starting to see dedicated hardware, especially for training and for inference, so a lot of these neural processing units that are going into the data centers. One of the things that we've been investing a lot at Huawei is we have created a brand new hardware architecture for how do you optimize around both training as well as inference speed and power efficiency when you start to deal with workloads. So this is what we call our DaVinci architecture. And what we've been able to do with this DaVinci architecture is a couple really interesting things. The first is that we've been able to scale this up into really, really massive data centers. So we just released this last month at our Huawei Connect conference in Shanghai, but we set the world record for the single fastest AI cluster in the world right now. So you can take a look in terms of a lot of the benchmarks that we've released. But right now, we can significantly increase the speed at which you do a lot of the training across your cloud data centers, and we can do it at a much higher power efficiency compared to a lot of the other typical neural processing processors that are out there. The other thing that we've been doing, though, is we've been scaling this architecture all the way down into smaller footprints, because if you really want to be able to run AI everywhere, you need to be able to run both inference as well as training. So inference is where I actually take my trained algorithm, and then I start to perform my intelligent analysis. And then training is where I suck in all that data and I do all the machine learning. And you need both to be hardware accelerated. And so we can take the exact same chip architecture and scale it down into your mobile devices. So for example, this is N310. This is the version that we can start to scale down into your mobile phones. And across this, it's a little bit hard to read here, but we can scale up and down all the way even into the same processor into a little earphone in your ear, because as you take a look at wearables, if you want to have AI inference in your smartwatch, if you want to have it in your earphone for an always-on voice assistant, you're going to need to be able to bring that into these areas where AI has been traditionally hard. You need to scale it up into the large cloud data centers because this is where all the training is going to happen. But if you really want to be able to run AI everywhere, you need to have the hardware platform that is going to be able to support this. And so this is a big investment that we've been doing because we need a new kind of processing architecture to be able to support that. So this is from the machine learning standpoint. The other hardware architecture, that we've been focused on is what do you do from a general purpose CPU standpoint? And remember, I had mentioned before, we're going to start to see a convergence not from cloud to mobile, but also from mobile back into the cloud. And there's a couple things that we need to do here. One is you need to be able to run your applications consistently across all these different architectures. And the second is you need to run them with incredible power efficiency. And so this is where we start to see the fact that especially ARM-based processors, which are coming from the mobile phone, are increasingly becoming powerful. You've probably seen a lot of the latest benchmarks where now the ARM-based CPUs are extremely performance competitive compared with your typical x86 processor, but are able to deliver tremendous power efficiencies. And so when you take a look at these large scale workloads that you need to drive from a machine learning perspective, having that density and power efficiency becomes critical, but also the fact that I can take an application and deploy it onto a device, and also to be able to deploy it and write it in the cloud and seamlessly move back and forth is an important factor from an architecture standpoint. So at Huawei, we have our own Kunpeng processor. Kunpeng is a very high mountain range in China. And so this is based on our ARM development, and it's based on the same architecture that we put into our mobile phones, which have hundreds and hundreds of millions of processors every single year. We're driving that same architecture into the cloud data centers. And so from our Kunpeng architecture, especially when you take a look at these data-heavy workloads and these machine learning-heavy workloads, we are able to see tremendous increases both in speed as well as power efficiency across these. And so this doesn't mean that the general purpose x86 CPU is going away. It doesn't mean GPUs are going away. But as we move towards machine learning becoming the dominant footprint, and we try to drive this everywhere, it means that we need specialized hardware to be able to deliver a lot of the performance and application architectures that we need. So these are the two areas that we've been investing in. Kunpeng is also a system on a chip, so it's not just the CPU capability, but it also integrates my memory interconnects, my storage interconnects, and everything is delivered as a simple SoC that we can deploy into a wide range of different hardware platforms. And one of the big things that we've been doing here is that if you take a look at most of the other, especially hyperscale cloud providers around the world, Huawei also runs a very large public cloud. They typically restrict these optimized hardware only for cloud deployments and typically only in their own public cloud. What we are doing with our Kunpeng and with our Ascend processors is we are opening this up and making them available for everyone to use. Because we think that if you want AI to be everywhere, everyone has to have access to these kinds of different processing capabilities. And so we are making these available for everyone to use. You can embed them in your own servers, in your own devices, and everywhere that you need to go. But in order to drive AI everywhere, the first thing you need to do is you need to optimize the hardware around these capabilities. Okay, so that's from a hardware standpoint. Two new kinds of CPUs. One is around neural processing. Another one is around very efficient for data processing. From a software standpoint, one of the things that we've been working on at Huawei is an AI framework that we call MindSpore. This is in the process of being open sourced. It will be open sourced probably Q1 by 2020. So you can think of this as a highly efficient version of something like a TensorFlow or a PyTorch or another one of these AI frameworks. But there's been a couple optimizations that we've made in MindSpore. One is that it is very coding efficient. So we've simplified the way and compressed the number of lines of code that you need to write in order to be able to create machine language application. But the second is we have done a lot of optimization to take advantage of the DaVinci architecture. And so when you combine this open source framework with that open CPU, we are seeing tremendous increases in performance of the speed at which we can do calculations. So for example, here is where we take a look at another third-party tensor processor as well as TensorFlow from an algorithm, and we run it across ImageNet in terms of training, and we run the same MindSpore as well as Ascend architecture, and we are achieving about 2 times increase in the performance in terms of the training speed, in terms of images processed per second. So significant increase in terms of performance, in terms of what we're able to achieve. And this has been a big focus, and this is coming into open source at the beginning of next year. Second thing, you need more than just an AI framework. You also need an AI architecture in terms of how do we combine the framework along with the architectures and the chip processors. So this is what we call our CAN. So this is the architecture for neural network, computer architecture for neural networks. And this is also a framework that we are in the process of open sourcing. Because if you want to start to create these massive scalable clusters that can orchestrate a lot of these NPUs and then integrate them into your training framework, this also needs to be really easy to use, and it also needs to go into open source. So this is the other piece of AI software that we are open sourcing in terms of how do we not just have the framework, but how do we build a scalable architecture to support massive instances of these frameworks running on top of these new process architectures. third thing that you need, if we're going to start to go onto these new chip architectures, NPUs, as well as Kung-Fu ARM-based processors, you need a general purpose operating system to be able to run across these. So at Huawei, we have a Linux-based operating system that we call Euler operating system. But there's been a lot of optimizations that we've been doing to integrate this with a lot of these AI capabilities that I was just showing you. And this is to improve both the performance, but also leverage AI itself in terms of how do we self-optimize the systems, how do we improve the capabilities, and how do we start to make sure that you can get the full optimizations in terms of how you are able to leverage the hardware coming in from the operating system perspective. And this is also something that we are open sourcing by the end of this year. And so Linux itself, of course, is open source already, but a lot of the optimizations that we've been putting into Linux to be able to take advantage of how do we do intelligent scheduling, how do we deal with maintenance, all these other AI-enabled capabilities, these are the things that we are also open sourcing this year as part of this open source distribution around Linux. And then as we move up the stack and we think about what are the fundamental capabilities that you need from a machine learning standpoint, we're also taking a look at the database because the database is probably one of the most critical areas in terms of how are you going to collect all the data and how is that going to intersect both from a training as well as from a usage standpoint. So we have been taking a lot of those same AI technologies and we've created what we consider the first AI native database, which we call Gauss database or Gauss DB. What this is focused on is the fact that we can go ahead and now start to take this and apply machine learning so that instead of having a DBA manage your cluster, how do you scale it up, how do you scale it down, how do you tune it? This is auto-tuning, this is auto-scaling, and this is auto-maintaining of itself because of the fact that we're able to leverage machine learning. And a lot of the things that we've been able to find is that when we take these machine learning frameworks and we put them on our optimized hardware architectures, we can achieve significantly better efficiency and performance compared to what a human is able to do from a manual performance standpoint because we're able to constantly optimize in real time and we're able to constantly improve by analyzing what are we doing and what do we need to do to improve. And so compared to even constant maintenance from a very highly optimized person, we're able to significantly decrease the operational cost as well as significantly increase the performance. And this is also something we are open sourcing, and so this will be fully open source by June of next year. But this is all what we're doing from a software standpoint. So how do we open source the new AI frameworks? How do we open source the architecture in terms of how do we combine the framework with the new chipsets that are coming underneath? How do we build an operating system to sit on top of these new machine learning capabilities? And then especially from a database standpoint, how do we help you take advantage of that from a DB standpoint? Okay, so we've talked about the hardware layer, we've talked about the software layer. Now let me talk about the mobile and device layer. Because if you're going to have AI everywhere and you want your machine learning capabilities to be everywhere you are, you have to be able to take them into your mobile devices as well as all your other smart devices in and around your home, in and around your city and your infrastructure. So the first thing that we've been working on, and this has been getting some news recently, but this is a new operating system called Harmony OS. And this is a new microkernel operating system designed specifically for smart devices. And there's a couple of things that make this very different from any other operating system, whether it's Linux, whether it's Android, whether it's iOS, or whatever you put on all these different device architectures. The first big change is that this is a fully distributed operating system running on top of a microkernel. What do I mean by that? We have a very, very small kernel which is able to run across a wide range of devices from the smallest footprint that you can imagine, like a watch, all the way up to your phones and beyond. Every other part of the functionality, unlike in Linux or others, where you have drivers that live in kernel space and that integrate and start to make that very big, what we have done is we have created a distributed bus. And so all the different parts of the operating system can run on different kinds of devices that are physically separate from each other. So for example, you can have your microkernel run on your phone. You can have the display for that not remoted to another device, but natively running on your TV. You can have the same data being stored in your car and interacting. And so a lot of what we have been doing is how do we create a local distributed bus with extremely low latency and extremely strong real-time performance characteristics so that when you have a whole fleet of different devices that need to interact with each other, you can push the functionality and the data and the interaction across all these different devices in a seamless manner without having to round trip to the cloud. So this is hugely important because this means that you do not have to store your data in the cloud, especially here in Europe, where you're dealing with a lot of GDPR and privacy issues. It also means that you have control over your security and your privacy, as well as the efficiency of everything that you're doing. But this is hugely important if you want to drive an AI everywhere architecture, because when you think about all the data that is being trained and constantly improved across these devices, if you have to constantly improve your algorithm, send it back to your AI provider in the cloud, and then send it back to your device, highly, highly inefficient round-trip process that you have to go through. Here, because we can distribute everything across a distributed operating system running across multiple devices at the same time, we're able to achieve a lot of brand new use cases around how do things interact with each other. So a lot of people have heard about Harmony OS as an Android replacement, potentially for our Huawei phones. It can potentially run on a phone because it can run on any single device. The goal for this was not just to create a new operating system that could power a smartphone. The real goal of this was to say, how do we create a distributed operating system that can power a device everywhere and an AI everywhere world where we can have functionality distributed across this operating system that spans multiple hardware devices at once. Another thing that we've been doing, as I mentioned before, is that we have been driving this so that it focuses on a wide range of different devices. Just to show you some of the ranges of things that we are trying to put Harmony OS into. So computing things, obviously like a smartphone or perhaps an edge device, but also how do you create an intelligent microphone? How do you create an intelligent drone that drives around and can connect with other devices as they mesh together? How do you put this into your televisions? How do you put this into your car? These are all the wide ranges of different devices where we think that they should all be able to interact together in a distributed and decentralized manner. And so that when you start to think about how do I secure, how do I have consistent identity, how do I have consistent experience, all this, it's not that I have lots of different operating systems all deployed across this. I have to have an identity management system that integrates these all together. I have to remote them into a cloud system that centrally stores my data. That architecture does not work well across an AI device everywhere world. So by pushing a consistent operating system that can go into every single one of these kinds of footprints and being able to distribute the functionality across these devices with a single operating system, this is the target that we're going after with Harmony OS. Now, second thing, if you need to start to have a new operating system, you have to have a new tool chain across this operating system. And so this is our ARC compiler. So there's a couple things that we've been doing around our ARC compiler. The first is that this is the compiler that you can use to compile applications directly onto Harmony OS. But this is also a multi-operating system compiler as well as multi-language polyglot compiler. So one of the things that we've been focused on is not only can we compile applications onto Harmony, but we can take your existing Android applications and compile them using ARC compiler into native code onto your Android native devices. So we need to seed the ecosystem for how our developers are going to start to engage with Harmony OS. So one of the things that we want to do is to say, even if the only thing is that you continue to build Android applications, right now, as you probably know, Android applications, they run on a JVM basically across your hardware. They are not native bytecode that runs across the hardware. So what our compiler can do is they can take your Android applications and compile them down into native code, and that gives you a massive performance increase for your exact same application running on an Android platform. But now, because we are offering these same performance optimizations with no code to Android, and we are saying you can use the same ARC compiler now to recompile that application onto Harmony OS with very, very little change to your application, then it makes it very trivial to say, how do I bring my existing Android applications into this new Harmony operating system and be able to support both platforms at the same time? So this is the tooling strategy that we've been putting in place, and this is already open source. And so what we're doing is to say, we know that everyone is going to have their own favorite language. They're going to have multiple runtimes, especially when you take a look at different devices. There's an existing ecosystem, and there's new ecosystems that you need to go onto. What we are going to say is, especially when you start to look at Harmony OS across all these different kinds of different devices, whatever language you want to write in, you will be able to do that. You'll be able to compile that down into Harmony OS. And also, if you happen to be working, for example, in Java and Android, you will be able to take those and compile it down into Harmony with very little effort. And so this gives us a very strong capability to say, how do we have not just the operating system, but now how do we have the new tool chain to be able to create these applications on top of Harmony OS? Okay, so we've talked about, from a hardware standpoint, we've got these new chipsets with Ascend and with Kunpeng, new software from everything from AI frameworks to computing architecture to operating system to database, mobile and devices. How do we bring this everywhere? We have a brand new distributed operating system architecture, so we can really spread out the compute across these devices. How are we going to engage with developers around this? So I mentioned before that we had a Huawei Connect conference, which is our big enterprise conference in Shanghai just last month. But one of the things that we announced is that we are launching the second generation of our developer program with a $1.5 billion US fund to be able to seed how do we grow the developer ecosystem around these Ascend and Kunpeng architectures. Because if you're going to need to write to new architectures and new platforms, you need documentation, you need training, you need access to hardware, cloud resources, and so on. So we are investing a huge amount to be able to create this next generation developer program. This is one of the single largest fundings ever for a new developer program, because we're trying to put a brand new set of architectures and open source capabilities out there. And so you are going to start to see us ramp up quite significantly, and we've already begun. We've been hosting lots of different developer days around how do we work with Harmony, how do we work with Ascend, and so on, all around Asia, coming into Europe and other parts of the world. And so this has been a big focus for us. Now, if you remember at the very beginning of the talk, I spoke about the fact that we want to take AI everywhere, and one of the reasons that we need to start to see the architectures come from the device back into the cloud is because when we talk about AI everywhere, it means that we want to be able to write the application and to be able to deploy them across a wide range of different capabilities at the same time. So what we are focused on with our CPU architecture and our ARM-based architecture is that we can run the exact same code on your phone. We can run it on an edge device. We can run it into a cloud data center, and no changes because you are running the exact same processing architecture, and you can run the exact same operating system capabilities all the way up. The only question is, how big are you going to scale it up, or how small are you going to scale it down? And so the same developer tools that I use to say, how do I remote onto my TV, and how do I have that functionality running on my phone, I can take that and I can run it in my cloud data center at the same time, both for development as well as for production usage with no change, because I'm running the identical computing architecture, hardware platform, operating system capabilities, all spread across everywhere that we're doing. So our goal is for developers to have as easy a process in order to be able to write these applications that have AI everywhere, because we're giving you not just new processing architectures, but new processing architectures that can go everywhere. Not just AI frameworks and capabilities around data processing that only live in the cloud, but that really are able to interact with your devices and that are really able to go across your phones, across your earphones, across edge devices, and across cloud, all with consistency, all being built on top of open architectures and open source software. So this is the summary of everything that I mentioned that Huawei is open sourcing. We've already begun for most of these. I mentioned we made these big announcements last month. Some of these we have already open sourced. All of these will be open sourced by next year. And so I think, if you just take a look at sort of this one-year time frame, this is arguably the biggest contribution ever to open source from a single company. So why do I say that? First off, if you look at Linux Foundation and Eclipse Foundation, their own reports in terms of what is the value of open source that they host. So Eclipse Foundation says they host about $10 billion of shared investment in open source software. Linux Foundation claims about $16 billion of shared investment. Just across these technologies alone, from a addressable market standpoint, Gartner expects that over the next 5 years, this is going to evolve into a $2 trillion market in terms of what is happening across here. So just the opportunity that these technologies are going to be sold into is massive. Just from a smartphone standpoint, Huawei has about 500 million daily active phones that check into our cloud services every single day. Every single one of these devices are going to be running these new Harmony operating systems as we go forward. And that continues to grow. You probably saw in the news just recently where our phone growth has been accelerating. So this year, we're about 25 million phones ahead of where we were last year already at this time last year. And so the addressable device space that we are opening up around these new operating systems is massive. If you take a look at our revenue, so last year we did about $105 billion US in revenue. This year we are significantly ahead of that. So we've already reported our first 3 quarters of revenue, and we're about 26% or so ahead of where we were last year. So still massive, massive revenue growth. And over the last 10 years, Huawei has invested about $70 billion of R&D across these. So none of this is to guarantee that these open source projects will become successful and massively adopted. But my point here is that this is a really bet the business point for Huawei, because we are saying we believe this is going to be the next generation of what architectures look like, because AI is going to go everywhere. If AI needs to go everywhere, you cannot take the existing cloud open source technologies and adapt them to what we need. You need brand new hardware, you need brand new software to power it, you need different architectures for how devices interact with each other and interact with the cloud. And so we have been developing and open sourcing every single one of these layers across the technology stack. And so this is why we think for us it's a hugely, hugely valuable and hugely important contribution. We're excited to be able to present this year, and especially where we announced this week that Huawei has joined as a strategic member of the Eclipse Foundation as of this week. And so one of the primary reasons that we joined the Eclipse Foundation at the strategic level and upgraded our engagement was to say, a lot of these new technologies, we believe that Eclipse will be the proper home to open source these technologies into, and also to integrate these capabilities into. Because when you take a look at all these new things, you need to be able to both host the projects, and you need to attract the developer base. And you need to have open governance and a very strong base of companies to work with. So we think Eclipse is a very, very good home to work with around all these different projects. And this is one of the things we're excited to work with all of you here in Eclipse around over the next few years. So with that, I want to thank you very much. And I think I've probably got a couple minutes for questions if anyone wants to ask anything. Thank you. Yeah. No, we are making the chips fully available for third-party vendors. So unlike, for example, a TPU from Google, or unlike a Gravitron ARM-based processor from AWS, anyone will be able to buy these processors from Huawei, embed them in your own systems, embed them in your own devices, use them as you want. Yeah. So we are optimizing this for our ARM-based architecture, because this is what our devices run on. It'll be open source, so if people want to do other things with it, there's no problem, but our own focus is on ARM. Yeah, so a couple things. One is that we expect this to be, the operating system that can go into a lot of these, IoT smart devices. The second is right now, there's a lot of good work in Eclipse in terms of how do you communicate from an IoT standpoint. We think we can both integrate with and simplify a lot of these things. So for example, there's Eclipse IoT projects around how do you do device management and how do you do deployment. I would love to see that integrate with Harmony OS so that you can manage a whole fleet of Harmony devices. On the other hand, the fact that this operating system is intrinsically distributed within the IoT ecosystem that you deploy, some of the messaging technologies and others, we can probably greatly simplify that because this is just a fundamental capability of the OS. Of course, you still have to communicate with non-Harmony OS devices. You still have to communicate back into your cloud data centers, so those don't go away. But at least for a lot of different IoT deployments, we think we can simplify a lot of what's going on there. Yeah, in terms of which ones are we going to host at the Eclipse Foundation and donate here, this is something that we have not publicly committed to yet. So we have been engaging with a lot of conversations, but there's a process that you have to go through when you open source any technology and when you start to work with the foundation. So what I can say right now is you can see our intentions, the fact that I'm here, the fact we've upgraded our membership, but there's always a lot of considerations in terms of what is the best approach. But Eclipse for us is a very logical home for at least a good portion of these technologies. Anything else? Okay. So the question is, do we see Eclipse framework as good for our compiler? This is one of the things that we definitely hope to do, is to take our compiler and the tooling around Harmony and then to bring it and to drive some tooling from Eclipse and Eclipse Che, because we see this as one of those most popular developer platforms in the world today. And so getting more developers to use this is absolutely a key goal for us. Okay, I think that's it then. So thank you very much.